Hello everybody, myself Sadat Sheikh, and today we'll be studying a very interesting topic called as Pseudo Force. And before entering into the topic, the definition and the concept, let us first visualize how these imaginary forces are being applied to us in our day-to-day life every day. I've just used a word called as imaginary force. Why I'm saying imaginary? Let us take a very basic example. For example, if we are sitting in a car or any vehicle, the driver of the car suddenly takes a left turn and we are, I don't know why, we are suddenly tilted towards the right side. If the driver of the car suddenly takes a right turn, we are tilted towards the left side. Nobody is pushing us, by the way. So an imaginary force is being applied to us when we are traveling in any vehicle. For example, the driver applies brake suddenly and we feel as if we are leaning in forward direction. Nobody is pushing us. So these forces which are being applied is called as pseudo force. So I've just used a word called as imaginary force. Pseudo means imaginary. Since it is a force, it is being applied to the body. Now we already know what a force is. We have already studied Newton's first law, second law in our school life. So till now we have understood, for example, this is a body of mass m. We can apply any external force to this object. So this body can accelerate. This body is having its own weight m into g, which is being balanced by a normal reaction. And so these are the forces which we have already studied in our lower classes. But today, what about these imaginary forces? These imaginary forces are not being shown in this free body diagram. So what are these? Now entering into the concept as mentioned in our NCERT or any standard book, let us understand one word called as inertial frame of reference. Now what is this inertial frame of reference? So can I say by definition it says that inertial frame of reference is any frame in which Newton's law of motion is valid. Oh, Newton's law of motion is valid. So inertial frame of reference says that a frame in which Newton's law is valid. So this is a very heavy statement. So what I will think over it is that, is there any other frame in which Newton's law of force is not, Newton's law of motion is not valid? Yes, there is. And we will take an example very shortly. Now what is Newton's law of motion? Basically, can I say F is equals to ma? Very briefly, basically this is the derived part of Newton's law of motion, but yes, generally we can say F is equals to A. Ma is Newton's second law, and this second law, since it is a law, it should be valid in each and every case. But now, while studying pseudo force, the book says, the reference book says, physics says that inertial frame of reference is in which the Newton's second law, first law, third law is valid. Newton's law of motion is valid. Now what is inertial frame of reference? Let us take an example. For example, consider, let us take a lift being accelerated in upward direction. Let us take this lift being accelerated in upward direction, and inside this lift, let us take a block of mass m. And there is a person who is standing outside this lift. Now this person, for example, the name of the person is A. What A feels that the lift is accelerating upwards. There is some kind of tension in this string, and if we apply free body diagram, this will be the tension in the string, this will be the weight of this block, and if we are applying Newton's second law, we can easily say, can I say T minus mg is equals to m into a, since acceleration is a positive y-axis. Absolutely no concern regarding this. So whatever we have studied till now is called as inertial frame of reference. It means the frame in which the observer is at rest. Very carefully now. The observer is at rest. The acceleration of the observer is zero. Wherever the observer is at rest, we say it is called as inertial frame of reference. No problem in this. We have studied everything to this concept previously, but today, since we are studying pseudo force, I will consider a frame in which the observer is not at rest. So this is my non-inertial frame of reference. Now what is this non-inertial frame of reference? Can I say my non-inertial frame of reference will be a frame of reference in which Newton's law of motion will not be valid. A very important statement. Newton's law of motion will not be valid. Newton's law of motion will not be valid. It means if I am applying Newton's second law, I will be getting a wrong equation. How? Again, let us take the same example. There is a lift and the lift is accelerating upwards and there is a person inside this lift. Lift is accelerating upwards as we have seen previously. I have taken the same example. Again, there is a rope or a thread in which a block of mass m is hanging. Now the person, the observer, is now inside this lift. Let us name this observer as observer B. Now when the observer B is watching this block, can I say as per the observer the block is at rest? The block is at rest. The block is not accelerating. So for him, the free body diagram will be, this is my tension in the string, this is the weight of the block. So T minus mg is equals to, yes, as per the observer, the block is not accelerating. It means acceleration is zero. Hence, T minus mg is equals to 0. So, as you can see from equation 1 and equation 2, there is a lot of difference. This was 100% correct. This is not correct. T minus mg is equal to 0, which is absolutely wrong. We should be getting this, but we are not getting 5. The only reason is the observer is not at rest. The observer is accelerating inside this lift. So when the observer is not at rest, previously he was at rest, we were referring this as inertial frame of reference. Now the observer is not at rest. It means he is in non-inertial frame of reference. Newton's law of motion will not be applicable. Hence we are getting a wrong equation. This is my pseudo force concept which will now be applied here. How to apply? How to correct this equation? How to correct? What we will do is, since the person is accelerating, the observer is accelerating in a certain direction, positive y-axis, we will just apply an imaginary force. Yes, imaginary force, pseudo force in opposite direction. So this imaginary force, let us take this as m into a, exactly in opposite direction. Whichever direction the person is accelerating, the observer is accelerating in the opposite direction, we have to apply imaginary. I have just mentioned at the beginning a very day-to-day example. The car takes a left and the person is tilted towards right, opposite direction. If the car takes a right and the person is tilted towards left, again opposite direction. Here we are applying the same concept. Since the person was accelerating upwards, the pseudo force should be applied in opposite direction. Let us now rewrite Newton's second law. Can I say T minus mg, T minus mg minus ma is equals to, For the person, this block is at rest, so there is no acceleration. Hence, we can rewrite this equation as T minus mg is equals to ma. Equation 1 and equation 2 both are now valid. Absolutely no problem. Let us take few more examples in which the concept is being used on a very crucial manner. For example, I will take, let us take a bogie of a train. Yes, why not? Now this example is also mentioned in most of the reference books. Let us take this as a container or a bogie of a train, and this bogie is accelerated in this direction. There is a person, there is an observer inside this bogie. Yes, this is my observer. Let us name this observer as O. Observer O. And I am just connecting a string on the ceiling of this container. And let us attach a bob, a solid sphere, a bob to this string. So what's happening when the bogie or when the container starts to accelerate, this string will be tilted on this particular direction. So this is my bob, and it will be virtually at rest. Since the train is already accelerating, this bogie is already accelerating as per the observer. This is my position of the bob. In the numerical, they will ask at which angle this string is inclined. Let us take this angle as theta. They may also ask what is the tension in the string. So for that we need to draw this free body diagram. This is my tension in the string. This is the weight of this bob, m into g. Is there any force which is being missed? Yes, a force, imaginary force, or we can say pseudo force. Since the block is accelerating, since the bogie is accelerating in positive x-axis, I have to apply an imaginary force in opposite direction. So this will be my imaginary force m into a. Now we can always write Newton's second law. Now since we have already considered the imaginary force, now Newton's law of motion will be valid. Now the students ask why Newton's law of motion is not valid. Again, I have already answered. Since the observer is not at rest, how to correct that? For need to correct, we need to apply that imaginary force in opposite direction, and we have already applied. Can I say T? Acha, this T is also in first quadrant. We need to resolve this. Since this is theta, this is also theta, so this becomes T cos theta, and this will be T sin theta. Can I say summation of force along x-axis is m into a, summation of force along y-axis is m into a. This is my Newton's law. I am applying Newton's law along x-axis as well as along y-axis. As I can say, in x-axis we have t sin theta is equal to m into a. Basically t sin theta minus m into a is 0. Why 0? Because as per the observer, this bob is at rest. This bob has just tilted in this particular direction, and now it is at rest because the train is now in constant acceleration motion. Similarly, along y-axis, can I say t cos theta is nothing but m into g. We can easily divide this t cos theta and t sin theta with itself. Can I say if I am dividing equation 1 with equation 2, what will I get? Equation 1 with equation 2, can I say tan theta is equals to mg. Yes, sine upon cos is tan theta, and ma divided by mg is a by g. So I can say what is theta? Tan inverse of a by g. So if we are finding the angle in this particular type of numerical, we can easily get or they may also ask acceleration of this bogey. So we can also say what is acceleration g tan theta. So in either way we can write. Sometimes they may also ask what is the tension in the string. We can also mention tension. We can easily find out tension. What we can do is just apply basic mathematics knowledge in this. Can I say if I just square and add these two equations, I will just square and add these two equations. So what will happen? Can I say t square sine square theta plus t square cos square theta is, can I say m square a square plus m square g square. I can take m square as common, and if I am taking t square common over here, sine square theta plus cos square theta is 1, so t square is equals to m square a square plus g square. So I can easily find out what is tension in this string, m under root of a square plus g square. It is very easy to find out tension in this particular case. Also there are various cases, by the way. Let us take another case. For example, there is a wedge. Let us take another example of pseudo force in which we will be applying imaginary force in the direction opposite to the acceleration. So they are asking, let us take that particular case. For example, there is a wedge and there is a small block being kept on this wedge. For example, this is my block like this. The mass of this block is small m. Let us take the mass of the wedge as capital M at an angle theta. Let the angle of the wedge be theta. So what they will be asking is what acceleration should be provided to this wedge. What horizontal acceleration should be provided to this wedge so that this small block of mass small m should remain at rest. This block should remain at rest. Now, why it is not remaining at rest? If I leave this as it is, if I am not applying any acceleration, the block will slide down. Of course, there will be some friction that will oppose, but generally it will slide down. I don't want that. What I want is, I want this particular block to be at rest, and for that I need to apply a certain horizontal acceleration. What that horizontal acceleration should be? So again we will be drawing the FBD free body diagram. Can I say this is my weight of this block m into g, and by applying Newton's second law, by the way, there is a normal reaction which is being balanced. This angle is theta, so of course this mg should be resolved in terms of mg cos theta and mg sin. See, this is theta, so this will also be theta. This automatically becomes mg cos theta and mg sin theta. So this is the way we generally resolve any vector, any forces in a free body diagram. Now, can I see? Since the horizontal acceleration is being applied, there has to be an imaginary force that should be applied in opposite direction. This is my imaginary force in the opposite direction. As I can see, this imaginary force is now in opposite direction, which should be resolved. Can I say this MA can also be resolved in terms of its cos and sin component? Then this is theta, this is also theta. So this becomes MA cos theta, and this will automatically become MA sin theta. This is the entire FBD of this particular situation in which pseudo force is being applied. Now the rest part is very simple. We need to just use Newton's second law. Can I say summation of force along x-axis is always m into a? summation of force along y-axis is also m into a. We have x and y-axis. This is my y-axis. This is my x-axis. Can I say ma cos theta is nothing but mg sin theta? There is an observer in this wedge. For him, the block should be at rest. That's what we are finding out. If the block to be at rest, what horizontal acceleration that should be provided? Can I say ma cos theta is equals to mg sin theta? Again, mm getting cancelled. Can I say sin upon cos is tan? A is equals to g tan theta. So this will be my horizontal acceleration that should be provided to this wedge for the small block to be at rest. So this, in this way we can easily find out acceleration of this wedge. Again, a simple concept. What we are doing is just apply an imaginary force in opposite direction. Let us take one last case. What horizon? Again, I am taking a wedge. Let us take another wedge, in which there will be again a small block. Now I don't want this block to be at rest. No, I want this block to be in free fall. So what they will be asking is, what horizontal acceleration should be provided to this wedge so that this small block should be in free fall motion. It means for the block, the small block to be in free fall, I need to accelerate this block in this particular direction. Yes, absolutely. So my acceleration should be in this particular direction so that my block should be in free fall. This is in our day-to-day life we can apply this concept. For example, this is a glass of water and let us take a cardboard being applied at the top of this glass, and I am just keeping a small coin. Let us keep a small coin on this glass. So if I flick this cardboard at a particular acceleration, if I am flicking this cardboard at a particular acceleration, this coin will fall freely inside the glass. Not every time, of course, but that particular acceleration that should be maintained. If I am maintaining that particular acceleration, this coin will fall inside this glass freely. This we can apply in our day-to-day life, in our kitchens. Now this is actually a physics concept which is now being applied in most of the numericals. I am applying acceleration in this particular direction. The block will be in free fall. Since the block is in free fall, of course, there won't be any normal reaction. So this is my own weight. The acceleration is in this direction. So my imaginary force, that is m into a, I am just highlighting this with a separate color so that it resembles a difference. This is my imaginary force, m into a. Now let us take the angle of this wedge as theta. No problem in this. Previously also it was theta. If this is mg, so I will resolve this in terms of mg cos theta. If this is theta, this is also theta. Now this becomes automatically mg sin theta. Again, ma can also be resolved very easily. Can I say, if this is ma, so this will be my cos and sine component, this is my theta, so this will automatically become theta, so this will be my ma cos theta, and this will be my ma sin theta. So I can see this block, since it is in free fall, I am not applying normal reaction because it is in free fall motion. So with the help of this FBD, can I say my ma sin theta is nothing but equal to mg cos theta. So mg cos theta is equals to ma sin theta. Again, mm getting cancelled, sin upon cos will become tan. Can I say g is equals to a tan theta? Sin upon cos has become tan. What horizontal acceleration to be provided? What is that particular acceleration? It has to be What is A? G upon tan theta. Yes. This will be my horizontal acceleration that should be provided for this particular wedge, so that this small block of mass m should fall freely. So we can do multiple numericals by just applying one concept. Wherever there is a pseudo force, imaginary force being applied, or whenever the observer is not at rest, it means it will be non-inertial frame of reference. For that particular reason, when the horizontal acceleration is in particular direction, opposite to that, we will apply our pseudo force or imaginary force. Thank you so much.